Welcome to this video. My name is Mark Scythian. The date today is May 2nd, 2025. So this lecture is going to focus on Pneudraulic Architecture. So that is the pneumatic force input to get hydraulic force output. So that's how many hydraulic systems are actually set up to have an input cylinder with a considerably smaller piston. So let's say the input cylinder is 2 inches in diameter, and then this time we have a hydraulic manifold that connects to 3 different actuators. So we have the purple, the blue, and the green actuator pistons, and they're connected with their locks. And then they have a variable cylinder diameter each one. So here's the diameters. And then we fill this input side, the hydraulic side, with a liquid, and we bleed out all the air or gas. So now the system is a hydraulic, i.e. incompressible liquid that of course takes the shape of the container, but it is not compressible, so it behaves like an amorphous or flexible solid, provided we bled the hydraulic system of any air or gas. Then on the input side we connect a air compressor, compressed air. And so we connect this to a valve, and then we introduce compressed air to exert the input force. So the force in this case is the pressure, air pressure times the piston area, because we know that pressure is the force divided by area. Case in point, pounds force per square inch, PSI pressure. So if we were to multiply the pressure times the area, we would then get the force exerted on the input piston from the pressure of the compressed air. So we have the input pneumatic and output hydraulic. So that is the Pneudraulic application. In this case, it is a Pneudraulic architecture. So let's say the small piston can displace a maximum distance of 10 inches for its cycle. And then we introduce 50 psi of air pressure. We open up the valve here and we introduce exactly 50 pounds per square inch of air pressure into the small piston. So we can take the 2-inch diameter and we can divide it by 2 to get the radius, then square that value. So 2 divided by 2 is 1 inch radius squared times pi means the small piston input has a piston area of 3.14 square inches of piston area. So we could then multiply the 50 psi air pressure, compressed air pressure, times 3.14. So we compute the input piston has an output, or at least the input force, of 157 pounds of force, which displaced this small piston 10 inches. And remember, the hydraulic fluid, the liquid, is not compressible, so we'll have some displacement by distance and by force amplification, hence a hydraulic system. So we can have an input force of 157 pounds force. So if we were to divide that by 3.14 square inches, pounds per square inch, we would then get a pressure of 50 psi. Now the 50 psi is going to consistently distribute across the entire hydraulic system. The only thing that will change is the piston diameters, and of course the force amplification and how much they displace. That will only be the variables. Constant remains the pressure. So once you solve for the pressure, all you need to do is solve for the area of all the pistons, so 2.5 inch diameter divided by 2, square it for radius times pi. So the the purple piston, the first one, 2.5 inch diameter piston, the purple one, will have a piston area of 4.91 square inches. So we just multiply 50 psi times that value, and then we calculate 245.5 pounds of force. And then if we want to know the displacement, remember the input piston is 10 inches. We want to know the displacement of the purple output hydraulic piston. And so we can just take the ratio of the input force divided into the output force, but because the purple piston is a larger diameter compared to the input piston here, so the displacement's going to be less. So we can always divide the lower number, 157 pounds input, into the higher number, 245.5. Then that ratio multiply times 10 inches. So the purple hydraulic output will displace 6.4 inches and exert a force amplification to 245.5 pounds force. So we repeat the process for the blue piston, the 4 inch diameter divided by 2 squared times pi. So the blue piston has a piston area of 12.57 square inches times 50 psi. So that's 628.5 pounds of force, and then its displacement is 157 divided into 628.5 times 10 inches, so it's 2.5 inches. So we write that in there. And then we follow the last calculation, 6.5 inch diameter green hydraulic piston actuator divided by 2 squared times pi, so 33.2 square inches times then 50 psi, so we calculate 1,660 pounds of force, and then a displacement equal to 157 divided into 1,660, that ratio times 10 inches, so 0.95 inches. So we write this in here. So the main takeaway is that once you figure out the input pressure, you'll know all the output pressures. So all you're going to do is multiply it times a different cross-sectional area. And if it's a bigger piston, which it usually is for the output, it's just the ratio of the input force to the output force times whatever the input small piston actuation or displacement is. So the main takeaway is that the input pressure is equal to the output pressure, and hence is constant. And then lastly, pressure is the ratio of force divided by area, and pressure-based force is equal to the pressure times the area. So thank you for watching this video lecture, and have a great day.